Back in Chapter 1, we had the introduction to equations, but in Chapter 2, we're spending a little bit more time in details and adding in some different varieties as well. We did start off last week by talking about the translations, and I want to always go back to that because that's going to be very helpful when we're solving word problems, when we have to assign variables and translate. So let's take a look at some translations just to start us off today. The sum of a number and 4 is, if you remember from last week, is becomes my equal to sign. So this is now a mathematical sentence. Sum means add. So again, give yourself those little hints. The sum of a number, you choose the variable. If they do not give one, n and 4. Okay, the sum that says add is 9. We don't have to solve these, we're just translating. We know product means multiply, and we know is, once again, is equals. It could actually say equals too. We've tried some of those already. The product of 6 and a number, let's just say 6x, is 12. So these first two are just one-step equations. The difference of a number squared and 1 is 3. The difference means we're subtracting. The difference of a number squared and 1 is 3. And there are just a couple quick translations, and like I said, we'll do a few from time to time just to keep this skill fresh. So we have talked about multi-step equations before. Let's look at a couple of two-steps. Equations that require just even more than one step to isolate the variable are called the multi-steps. We can use two inverse operations. We've already encountered the combining like terms. Then we even have the distributions. But we're going to add more to it because we're going to start seeing fractions in the mix as well. Let's start by this first two-step here. Let's add 4 to both sides. I have 11x is equal to 33. We'll divide. We'll get x is equal to 3. I find it important to do the check from time to time, and sometimes it will be required. So let's look at the check. You take the value that you found and replace it into the original equation for the variable. You then do the math. This says 33 minus 4. That equals 29. It checks. The next problem has a combining like terms, so we'll combine. We'll divide. And then we get our solution. X is equal to 21. We replace 21 in each of these variables, and we'll see that we have the correct answer. Sometimes the combining like terms might require us to combine constants. We'll then do two inverse operations here. We'll subtract first, and lastly we'll divide. And our solution is x is equal to 5. Well, 5 times 8 is 40. 40 plus 9 is 49. Subtract 3 gives us 46. We should remember that sometimes our variable will be on the right instead of the left. We'll still be isolating the variable. And once again, we see a multi-step. We'll divide. And that gives me 10 is equal to x. So I like to do what we call interchange. And what does interchange means? We're just going to change places so that what we're solving for, which was x, comes first. Now, as I mentioned, we were going to see some that were slightly different than the ones we saw in Chapter 1, and here's one of them. A plus 7 divided by 8 equals 5. If I say it out loud like that, I hear that this fraction bar is a division symbol. So the first thing I'm going to do is multiply both sides by 8. That will cancel out on the left, leaving me with a plus 7. And then I'm going to multiply here and get 40. All I do now is subtract, and I get a is equal to 33. Let's try one more of those. X minus 4 divided by 5 equals 3. We start off by multiplying both sides by 5. Cancels on the left. X minus 4 is equal to 15. Add 4 to both sides. I get X is equal to 19. Did you say we should check? We should. 19 minus 4 divided by 5. That gives me 15 divided by 5, which equals 3, and it works. Nothing unusual about the one on the left, just subtract 20. That gives you 4x is equal to 216, and you're going to divide by 4. X is equal to, that's 54. Now here's where I started talking about something a little different, which has the fraction coefficient, which I'm sure I mentioned in the past, but it takes, it's pretty important that we take a closer look at it. I'll first add 25 to both sides. That will be the first of 2 steps. I'm going to add it here, and I get 2/3 times x is equal to 140. In order to eliminate that fraction, we multiply by the reciprocal. We did a few of these in the one step last week. Everything cancels on the left because any number times its reciprocal equals 1. And then I can cross cancel 2 into 2 once, 2 into 140, half of that is 70. 70 times 3, 210. Okay? Just trying to give you different types so that we can practice a little. Let's go back to those division ones again, because those sometimes trip people up. You want to start by multiplying both sides by 2. That will cancel the 2's on the left. N minus 1 is equal to -10. Add 1 to both sides, and here we start practicing working with our signed numbers because we are dealing with integers. Okay. One last one. You do that, and we'll check that one in class. The last thing I want to talk about is one of those word problems that I was referring to at the beginning when I said we needed to do some translation. We're going to be talking about consecutive integers. Consecutive integers are numbers that are in counting order. They follow one right after the other. 4, 5, and 6 are consecutive numbers. They can be represented by let n be the first number, n plus 1 the second, and n plus 2 the third. So let's put that into a word problem. We're going to write an equation for this problem and then solve it. Find 3 consecutive integers with a sum of 159. So we already know the sum. We know that we're going to be adding. So in that previous slide, I said let's let n, we have to assign a variable. Let n be the first number. N plus 2, because that's one more, will be the second. And n plus 3 is the third. And we know that it has to have a sum of 159. So it now looks like n plus n plus n would give me 3n. And the 1 plus 2 is 3. So that gives me 3n plus 3 equals 159. We'll now solve this two-step equation that we created. That will leave me with 3n is equal to 156. We'll divide both sides by 3, and n will be equal to 52. Now 52 is my first number, that's n. So n is equal to 52. N plus 1 more will be 53. And n plus 2 more will be 54. It's always good to check to see if it worked out. 4 plus 3 is 7. 7 plus 2 is 9. 5 plus 5 plus 5, 159, and it checks. Let's see another. Find 3 consecutive numbers that total 192. We have that same setup. N is my first number. n plus 1 more is my second, n plus 2 is my third, and it equals 192. I just can remember that it's n plus n, combining like terms. This is a multi-step, and 1 plus 2 is 3. If I'm looking for 3 consecutive numbers, we're always going to have 3n plus 3. You now subtract and divide and find your 3 numbers. I'll leave you with one more to look at. See if you can try this one, and again, we'll go over that in class. See you then.